So, hi everyone. There we will be beginning with arenes. Benzene is the same thing, and this is after the introduction of functional groups. Do watch those videos because if you do not have any idea about the functional groups, then there is no way that you can get hold on the organic chemistry of plants because those are the basics. So what arene is basically a six carbon compound, and you must have been familiar with this ring. These double lines are representing the double bonds, and these double bonds can be on different positions, which we say alternative positions they can have. But the ring remains the same, and that is why we represent it with through a circle as well. That's a Kikuel structure. That represents that this pi electron system is delocalized. I hope you remember that a carbon-carbon have a single covalent bond. That means it's a pi overlapping, but double represents automatically the sorry, if single then sigma overlapping, and the double means pi overlapping for sure. Now, this makes it the delocalized pi electron system make it a very electron rich compound. So electron rich means that they will not going to have nucleophilic reactions. I hope you know that when we say nucleophilic reactions, what do we mean by that? Nucleophilic means reactions that are happening because of nucleophile and nucleophile atoms, or maybe the group of atoms which have a negative charge. However, when we say electrophilic reactions, that means an electrophile is involved, and electrophile means that it has a positive charge on it. Now, since they are electron rich, so do they have the electron charge density, the negative electron charge density. That is why they are more into attracting the electrophiles, the positive ones, not the negative ones. Do they do addition reaction? No, not easily possible in benzene. However, the expectations are maybe then in benzene, the addition reaction can also be very much possible, as in alkene is very much possible, because alkene does again means a double covalent bond between two carbons. But that's not the possible because the strength reactions are very much dependent on the strength of the bond. That is dependent on the distance of valence electrons or the shared pair of electrons from the nucleus. It is also dependent on the symmetry and the charge density as well. And as far as benzenes are concerned, they got stability. Whosoever is stable, either you are talking about a human in their real lives or you are talking about the compounds in chemistry, stability makes you less reactive, makes a person less impulsive. So you need to be stable first, then you're not going to react unnecessarily. Yeah. It's a very stable compound, and the stability comes because of the delocalization of the bioelectron system, because this negative charge is spread out over the molecule evenly. So this even, spreading out of the charge is also very, very important, no matter you are a negative person or you're a positive person. That needs to be stabilized. We're supposed to be a positive person. Why not? Anyways, moving on. The reactions that benzene does is substitution, nitration, Friedel-Crafts alkylation, Friedel-Crafts acylation, complete oxidation, and hydrogenation. These videos are not just to give you the details. You want details, you have to watch the video and ask me the questions directly. You can write in the comment box. I'll definitely going to check it. As far as this are concerned, is to give you an overview. The typical questions, the whys and hows, I'm going to discuss in the past papers thing. Past paper solution video. Substitution reaction happening with it's basically electrophilic substitution reaction. Electrophilic means an electrophile will going to be involved, which is atom or compound or the group of atom have a positive charge. Substitution means definitely going to replace something, and that is hydrogen in case of arenes. Chlorine and bromine, they will work as an electrophile. Now, that's very surprising because when we say halogens, all the first thing that comes in our mind is a negative charge on them. But here, the things are going to be different. But this has to happen in the presence of anhydrous. I hope you know the meaning of anhydrous, that is without water. Aluminum chloride, trichloride, and aluminum tribromide. The product we get is a halogen arene, which means a benzene ring. We will have a halogen attached to it. As I told you, they both were going to react with an electrophile and replaces a hydrogen atom on the benzene ring, which makes it an electrophilic substitution reaction. If you see the reaction in one go, it happens when arene is reacting with bromine molecule in the presence of aluminum tribromide. That has to be anhydrous. And it's better if you write down over here, if you will get bromobenzene along with hydrogen bromide. But that's not a very simple reaction. It happens basically in step. So in the first step, what you will be getting, in the first step, you'll be getting an electrophile. How that happens? See, these two buddies, when they are together, I mean, when they are in relationship, when they are bonded together, they are bonded together in a way that they are sharing the electrons. But when the breakup happens and when they have to get separated, so one has to be positive who will listen to the sad songs, and then the other has to be negative who play the evil character. So this bromine, it will take away the shared pair of electron along with it, and automatically it will get a -1 charge. Why? Because one electron was already belonged to this bromine, and this one electron has been taken from the other bromine. So that is why it's getting -1, because eventually the bromine is getting one electron. And this one, the poor one, will get a positive charge and will serve as an electrophile for the further step. Now, this one, of course, can't live alone. It has to get stabilized with someone. So it will going to form a dative bond with aluminum tribromide. I hope you know about the dative bond. If not, then you can see my video of chemical bonding. And this is what we will be getting, but it's temporarily. And keep it in your mind that this aluminum tribromide will not going to let this bromine live forever. They're going to release this bromine very soon, step number 3. Next, the one which just broken up from the other bromine will going to attack this benzene ring, and they will have an intermediate. The basic thing that you need to see over here is it's a full aromaticity, means a delocalized electron, pi electron systems all over there. However, in this case, the aromaticity is lost, and the both of them, bromine and hydrogen, are there in one compound, and this is an intermediate stage. Step number 3, the intermediate, it will, from this, hydrogen will be released. When hydrogen will be released, as I told you, that aluminum tribromide will not going to keep the bromine for a very longer time period. So they release the bromine that they had it from the other bromine molecule, and this hydrogen and bromine will be together forever, living happily ever after. And here we will be getting a halogen arene, which can also be called as bromobenzene. Catalyst will be restored in an original form, and that's what catalysts are all about. They do participate in the reaction that they get restored. You can practice the reaction of benzene and chlorine by pausing the video, because the steps will going to be the same. At every step, the bromine will be replaced with chlorine. Another reaction is nitration. Nitration, one simple reaction would be that benzene is reacting with nitric acid. Nitric acid is a mix of concentrated nitric acid and sulfuric acid with a temperature of 25 and 60 degrees centigrade. So why is it a mix? Again, you can leave a question and interested candidates can get the answer. You can join my classes also. And what we are getting a nitrobenzene along with a water molecule. Now, before we move ahead, benzene is just not about the reactions of benzene. This is also about the reactions of alkyl benzenes. I mean the derivatives of benzene as well. Alkyl benzene means an R can be placed over here. Now this R can be a methyl or can be an ethyl. Methyl, if it is attached, then it is methyl benzene. And generally you will see the examples of methyl, and this is also called as toluene. If ethyl is attached, automatically it will be ethyl benzene. So if I see the first reaction, which is substitution of halogen, that if methyl benzene is there, and this methyl benzene is reacting with a halogen in the presence of anhydrous ammonium trichloride. So what we will be getting? We will be getting 2 chloromethyl benzene and 4 chloromethyl benzene out of this, along with 2 hydrogen chloride molecules. Remember, whenever an alkyl radical is attached to a benzene, it will open the positions of 2, 4, and 6 for the upcoming atoms. Like if chlorine has to attach, then it can be a 2, 4, and 6 position. Let's suppose if I'm doing the reaction of bromine, excess means a lot of bromine, then three molecules of methyl benzene we're going to react, and what we'll be getting as a result, we'll be getting 2,4-dibromomethyl benzene. We'll be getting 2,4 2 bromomethyl benzene, and of course you'll be getting 2,4,6 tribromomethyl benzene. Please excuse my writing. Intelligent people have very bad writing. Just kidding. And hydrogen bromide as well. So these are the products when bromine access will be there. And if same, the methyl benzene, which can also be known as toluene, is reacting with nitric acid, then it will be, can give us orthonitrodoluene and paranitrodoluene. There are two ways to define the positions of benzene. One is to place the numbers as 1, 2, 3, 4, 5, 6, and the other is, say, ortho positions, meta positions, and para positions, and here the alkyl radical is attached. So both are correct. Now, Friedel-Crafts reactions. That's the third type. We did halogens, we did the nitration, and now Friedel-Crafts reactions. Our electrophilic substitution reactions here, benzene is reacting with a compound, can be, here it is chloropropane, heat with the presence of aluminum trichloride catalyst. The halogen will be detached over here, the hydrogen is coming from here, and it is giving hydrogen chloride, and this is propyl benzene. Now, this is the overall equation. In steps, if we go generating electropile as we did last as well, when chlorine will be detached, fluorine here is the devil or the evil one. We're going to take away the electron, which was shared between these carbon and chlorine, and here the carbon will get the positive charge, which we call carbocation also. And aluminum tetrachloride will be formed over here, which is a temporary thing. This positive side of the carbon will going to be attracted by the benzene, and loss of aromaticity, an intermediate will going to form, and this intermediate hydrogen will be released. Chlorine will be coming from the aluminum tetrachloride and from HCl. And we'll be getting what? We'll be getting the propyl benzene. This is very, very similar to what we did in the other steps. It's just that it's a larger compound that we are using over here. You can pause the video. You can do the practice with chlorobutane. You can do the practice of chloropropane, and you should be doing 3 steps reactions, clearly following the steps that we have discussed in the previous slide, and this will give you an insight of how to do it. And there is a question you can always come back to me and ask. Then comes Friedel-Crafts acylation. Alkylation means that a halogen group is attached to alkyl. However, here acylation means that this functional group is going to be changed with the COCl. And again, it is happening aluminum trichloride. If it's a bromine, then not in this case, but if there's a bromine, then aluminum bromide catalyst. And this is what you're getting at the end of the day. The halogen will be broken down from here and form hydrogen chloride. It's similarly the 3-step reaction as we did in the previous step. Oxidation. Alkylarenes, oxidation, they form carboxylic acid, which is refluxed with potassium magnate, then acidified with dilute sulfuric acid. When we say ethyl benzene reacting with oxygen, and it will be changing into what? Benzoic acid, and giving us what? Water. I repeat. Ethyl benzene reacting with 3 of oxygens and giving us benzoic acid. This represents the presence of carboxylic acid, or makes it, because this is a functional group for carboxylic acid. Now here it can be R, or it can be a benzene ring attached to it, and the water molecule. Then comes hydrogenation. This is the only sort of addition reaction that is possible in benzene. As we discussed earlier in the first slide, that the reaction with benzene, addition reaction with benzenes are not very easily possible. So benzene reacting with 3 hydrogen molecules in the presence of nickel and platinum catalyst give us cyclobenzene. And if ethyl benzene is doing it the same way, then of course we will be getting ethyl cyclohexane. Cyclohexane and ethyl cyclohexanes. When the double bonds are present, they are benzenes or arenes. When in these rings, double bonds are not present, then they are cyclohexanes. Again, they are hydrocarbons. They got this resonance effect, which is 5 electron system stability and 6 carbon hydrogen compound. Halogenation happening with chlorine or bromine in the presence of these catalysts and giving us aryl halides. Nitration is basically happening in the mix of concentration sulfuric acid and hydrogen nitride and nitric acid with a temperature 25 to 60 degrees centigrade and giving us nitroarenes. Photograph alkylation, halogen alkane reacting in the presence of anhydrous aluminum chloride and giving us alkyl benzene. Acylation, acyl chloride and anhydrous aluminum trichloride and giving us acyl benzene. Complete oxidation, hot alkaline came in a port and dilute acid, giving us benzoic acid. Hydrogenation, heating with hydrogen molecule, platinum and nickel catalyst or nickel catalyst and giving us cyclohexane. So this was the reactions of reeds. You can always check out the other videos, but now I'm tired and I'll come up with the recording of another video of the next compound. See you there.